So good morning, my name is Orna and I worked on a machine learning based analysis of indocyanine green assisted near infrared spectral data for diagnosing pancreatic carcinoma. So pancreatic cancer has the 7th highest cancer mortality rate in the world, and this is a general effect of a lot of late stage diagnoses. So other than biopsy, the main diagnostic method involves imaging, and these imaging methods tend to vary. There's no streamlined method. Among that, the data can be noisy, in the case of CT and PT, use ionizing radiation, and overall can be inefficient with human analysis and its execution. There are also low physical symptoms at early stages, which might be a problem in letting people being tested. As a result, not 80 to 90% of people get diagnosed at late stages and cannot qualify for cancer treatments. So a potential solution is to use near-infrared spectroscopy techniques with indocyanine green fluorescence as a potential non-radiative diagnostic method. And you could diagnose this a lot faster using machine learning methods rather than having individual humans examining the samples. So spectroscopy is generally whenever light is emitted into from a laser source, and it interacts with the sample with dye inside, and that has a certain level of absorption spectra. That is measured by a spectrometer, which records the wavelength, and spectrofluorometers, which record intensities with respect to dyes. These are then read out to computer files and produce data that can be recorded in graphs such as these, where we have the wavelength recorded and specific intensities spectra recorded. NIR itself is from 750 to 2,500 nanometers. This data was recorded from a human pancreas that we had gotten from a biopsy. As you can see in this human pancreas, we have a tumor region marked already and a normal region. We also have a margin, which we do not know if it's a tumor or not. This is for further analysis. And we have a mechanism that follows the previous slide's mechanism, but with a clinical setting. So my part of the project was doing the classification and analysis of the ICG fluorescence spectra in machine learning. So here we would diagnose